Hello guys, good day and welcome back to this channel once again. In today's video, we are going to continue our lesson on sequence and series. We are going to look at the geometric progression, that is GP, or the exponential sequence. Now the exponential sequence is a sequence of non-zero numbers where each term is obtained from the preceding term by multiplying by a constant non-zero number, or better still a constant factor, called the common ratio. So basically it is a sequence of non-zero numbers where each term is obtained by multiplying the previous number by a constant factor we call the common ratio. So for the geometric progression, in simplest form, if you want to get the next term, then you are going to multiply the common ratio or the common factor by the previous term. That is what we mean by the geometric progression. Now the general term for the geometric progression is given by un equals a times r exponent n minus 1, where a is called the first term, r is called the common ratio, and then n is the number of terms. Now, given that the first three terms of a GP are u1, u2, and u3, so first three terms, they are u1, u2, and then u3, then the common ratio r is equal to u2 divided by u1, and that is the same as u3 divided by u2. So to find the common ratio, it is basically the initial term divided by the previous term. So if u2 is the initial term, then we have u2 divided by u1, and also if u3 is the initial term, then when you divide it by u2, then that is the common ratio. Now back to the general term or the nth term of a GP, we have un equals a times r exponent n minus 1. This is the general term or the nth term. Using this same formula, we have u1 equals, now we are going to substitute 1 in place of n in this equation or in this formula. So that is a times r exponent 1 minus 1, and this is the same as a times r exponent 0. Now any non-zero number raised to the power 0 is 1. Therefore 1 times a is still a. We have u2 being a times r exponent 2 minus 1, which is the same as a times r exponent 1, which is a times r. Now I believe that you are able to guess the trend. Therefore, if you have u3, then u3 will be a times r exponent 2, and then u4 will also be a times r exponent 3, in that order. Now with this information, let's practice some examples. So let's take our first example. Find the seventh term of an exponential sequence of the form 5, 10, 20, 40, and so on and so forth. We are going to find the seventh term of this exponential sequence. So we said that the general term of an exponential sequence is given by un equals a times r exponent n minus 1, where we have a to be the first term, r is the common ratio, and then n is the number of terms. Now since we are going to find the seventh term, then we have n to be 7. From the sequence, we have a, which is the first term, to be 5. This is the first term. And then we are going to find the common ratio, since we don't know the common ratio. Now the common ratio is given by, we can have either u2 over u1, or better still, u3 over u2. We are going to get the same answer. So for u2 over u1, u2 is the second term, which is 10, and then u1 is the first term, which is 5. Now that should be equal to u3, that is 20, divided by u2, which is 10. 10 divided by 5 is 2. 20 divided by 10 is also 2. Therefore, the common ratio r is 2. Now, since we have the value of n to be 7, a to be 5, and then r to be 2, we can substitute all these three values into this expression to find the seventh term of the exponential sequence. So we have u7, that is, we are going to substitute 7 in place of n. So u7 equals, we have a to be 5 times r, which is 2, exponent 7 minus 1. We have 5 times 2 exponent 7 minus 1 is 6. 2 exponent 6 gives us 64, and then 5 times 64 gives us 320. Therefore, the seventh term of this exponential sequence is 320. Let's move on to solve our second example. So let's solve example 2 together. Find the 10th term of the exponential sequence of the form 324, 108, 36, and 12. Find the 10th term of the exponential sequence of the form 324, 108, 36, 12, and so on and so forth. Now, from this exponential sequence, we have the first term to be 324. We are going to find the 10th term, so n is equal to 10, and then we don't know the common ratio. Now, the common ratio is given by u2 over u1. We have u2 to be 108, and then u1 to be 324. Now 108 goes into itself once, and then into 324 3 times, so that is 1 over 3. So we have the common ratio to be 1 over 3. Now the general term, or the nth term of an exponential sequence, is given by un equals a times r exponent n minus 1. Now let's substitute the values of a, n, and r into this expression. So we have u10 equals a is 324 times r is 1 over 3, and then we have exponent 10 minus 1. This becomes 324 times 1 over 3 exponent 9. Now, according to indices, we can distribute the exponent to both the numerator and the denominator. So that is 324 times 1 exponent 9 divided by 3 exponent 9. One exponent 9 is the same as 1, and then 3 exponent 9 gives us 19,683. So we want to multiply the two so that we have u10 equals 324 divided by 19,683. Now 81 goes here 4 times, and then here 243 times. Therefore, we have the 10th term of this exponential sequence to be 4 over 243. So to example 3, the second and fourth terms of a GP of positive terms are 9 and 4 respectively. Find a, the common ratio, b, the first term. The second and fourth terms of a GP of positive terms are 9 and then 4 respectively. Find a, the common ratio, and then b, the first term. So from the question, we are told that the second term is 9 and then the fourth term is 4. Now the general term of a GP is given by un equals a times r exponent n minus 1. Therefore, the second term will be u2 equals a times r exponent 2 minus 1, which is the same as a times r, and that is equal to 9. Now let's call this equation 1. Now the fourth term, we have u4 equals a times r exponent 4 minus 1, and that is equal to a times r exponent 3, which is equal to 4. Let's call this equation 2. Now to find the common ratio and the first term respectively, we are going to divide equation 1 by equation 2. Therefore, we have equation 1 divided by equation 2. So for equation 1, we have AR equals 9. And then for equation 2, we have AR cubed equals 4. So A cancels out A, and this is R exponent 1. So R exponent 1 over R exponent 3 is 1 over R exponent 2. That is equal to 9 over 4. Now we are going to flip 1 over R square so that we do same to the right hand side. We are going to flip 9 over 4 to get 4 over 9. So that is R square equals 4 over 9. And then we take the square root of both sides of the equation, and that becomes R equals the square root of 4 over 9. Now this square cancels the square root. Now this is the same as the square root of 4 divided by the square root of 9 according to indices. Square root of 4 is 2, square root of 9 is 3. Therefore, we have the common ratio to be 2 over 3. Now let's find the first term. So we can use any of the two equations. So from equation 1, we have AR equals 9. Since R is 2 over 3, then we substitute this value here so that we have A times 2 over 3 equals 9. This is the same as 2A over 3 equals 9 over 1. Now we cross multiply, and then we have 2A equals 27. And then we divide through by 2 so that we have A to be 27 over 2, which is the same as 13.5. Therefore, we have R to be 2 over 3, and then we have A, which is the first term, to be 13.5. Now let's take another example on this same type of question. So for the fourth example, example 4, the third and sixth terms of an exponential sequence are 1 over 4 and 1 over 32 respectively. Find A, the first term and the common ratio, and then B, the eighth term in the sequence. So we are going to solve this question just as we solved the previous question. Okay, so we are told that the third and sixth terms of this exponential sequence are 1 over 4 and 1 over 32 respectively. So we have un equals a times r exponent n minus 1, that is the general term. So u3 is equal to a times r exponent 2, and that is equal to 1 over 4, equation 1. And then we have u6 equals a times r exponent 5, that is equal to 1 over 32. This is equation 2. So let's divide equation 1 by equation 2. So therefore, equation 1 divided by equation 2. So we have a times r exponent 2 equals 1 over 4 divided by a times r exponent 5 divided by 1 over 32. So this cancels out this, and then we are left with 1 over r cube. So we have 1 over r cube equals, now we are going to take the reciprocal, so we have 1 over 4, or better still, let me write it here, 1 over 4 times 32 over 1. This goes into itself once, into 32 8 times, so we have 8 times 1, which is still 8. So this is 8 over 1, and then we are going to flip this, so this becomes r cube equals 1 over 8, and then we take the cube root of both sides, so cube cancels out the cube root, and then this becomes the cube root of 1 divided by the cube root of 8. Now this is the same as 1 exponent 1 over 3 divided by 2 exponent 3 times 1 over 3. The numerator goes to 1, and then we have 3 cancelling out 3. 2 exponent 1 is still 2. Therefore, we have the common ratio r to be 1 over 2. Now let's substitute this value into any of the two equations. So from equation 1, we have a times r squared equals 1 over 4, and then 1 over 4 is the same as 0.25. So given that r is 1 over 2, we have a times 1 over 2 square equals 0.25. Now 1 over 2 is half. Square of it gives us 0.25. So we have a times 0.25 equals 0.25. We divide through by 0.25, and then we have a to be equal to 1. Therefore, we have the common ratio to be 1 over 2, and then the first term to be 1. Now let's find the 8th term of this sequence. So that is b. So the 8th term, we have u8 equals a is 1, and then we have r to be 1 over 2 exponent 8 minus 1. Now this is the same as 1 over 2 exponent 7. According to indices, this becomes 1 exponent 7 divided by 2 exponent 7, which is equal to 1 over 128. Therefore, the 8th term of this sequence is 1 over 128. Now let's talk about the sum of a geometric progression, or the sum of an exponential sequence. Now the general formula of the sum of the first n terms of an exponential sequence is given by Sn equals a times 1 minus r exponent n over 1 minus r where r is less than 1, or r is less than unity. Now in a case where r is greater than 1, then we are going to use the formula Sn equals a times r exponent n minus 1 over r minus 1. So you are going to use this formula when you have r to be greater than 1, or you have r to be greater than unity. So basically these are the two formulas that you can use to find the sum of the first n terms of an exponential sequence. Now let's solve some examples on that. So let's take our first example on the sum of the first n terms of an exponential sequence. Example 1. Find the sum of the first 10 terms of the GP, 1 over 2, 1, 2, 4, and so on and so forth. We are going to find the sum of the first 10 terms of this exponential sequence. Now from this sequence, we have a, which is the first term, to be 1 over 2. We are going to find the sum of the first 10 terms. So we have n to be 10. Now we don't know the common ratio, so let's find the common ratio. So the common ratio is given by, we have u3 over u2. Now u3 is 2 and then u2 is 1. So we have the common ratio to be 2. Therefore, r is equal to 2. Now, since r is greater than 1, then we are going to use the formula Sn equals a times r exponent n minus 1 over r minus 1. Since r is greater than 1, we are going to use this formula. Now let's substitute the values of r, a, and then n into this expression. So we have S10 equals a is 1 over 2, so 1 over 2 times r, which is 2 exponent 10 minus 1, divided by, we have r to be 2 minus 1. Now this is equal to 1 over 2 times 2 exponent 10. Now 2 exponent 10 is 1024 minus 1 divided by 1. And this is the same as 1 over 2 times 1024 minus 1 gives 1023. Therefore, we have the sum of the first 10 terms of this GP to be 1023 divided by 2. Let's solve another example on this. Now to example 2. The third term of a GP is 10 and the sixth term is 80. Find the common ratio, the first term, and the sum of the first 6 terms. So from the question, the third term of a GP is 10. We have un equals a times r exponent n minus 1. This is the general term. So the third term, u3, will be a times r exponent 2, and that is equal to 10. Let's call this equation 1. We have the sixth term, that is a times r exponent 5 equals 80. This is equation 2. We are going to find the common ratio, the first term, and the sum of the first 6 terms. So let's say equation 2 divided by equation 1. So for equation 2, we have a times r exponent 5 equals 80, and then divided by a times r exponent 2 equals 10. A cancels out a, and then we are left with r exponent 5 divided by r exponent 2 gives us r exponent 3, and this is equal to 8. So we take the cube root of both sides, and then we have r to be equal to 2. So this is the common ratio, r is equal to 2. So let's solve for a, or let's find a. So from any of the equations, from equation 1, now let's make this a. Okay, let's make this a, and then this will become b. So from equation 1, we have a times r exponent 2 equals 10, and then we have r to be 2. Therefore, we have a times 2 exponent 2 equals 10. This becomes 4a equals 10. We divide through by 4, and then we have a to be 5 over 2, which is the same as 2.5. So that is the value of a. So lastly, we are going to find the sum of the first 6 terms. Now since r is greater than 1, we are going to use the formula Sn equals a times r exponent n minus 1 over r minus 1. Therefore, we have S6 to be equal to a is 5 over 2 times r, which is 2 exponent n. N is 6 minus 1 over 2 minus 1, and this is equal to 5 over 2. Now 2 exponent 6 gives 64. So we have 64 minus 1 divided by 1, and this is the same as 5/2 times 63. 5 times 63 is 315, and then divided by 2. Therefore, the sum of the first 6 terms of this exponential sequence is 315 divided by 2. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.